Okay, so page 273 we're just going to do the chapter test and probably build a study sheet. Okay, so first things first, they're talking about a model airplane, which could be anything, right? It could be a model object, just like this airplane. It could be a diagram, like a blueprint. That's pretty much it. Like it's an object that's scaled down, or it's a blueprint of something. So you can see the ratio is given 1 to 128. So what does that mean? Because we always have to stick with this formula here. The model goes first, the original goes second. So it says that for 1 unit of the model, the original has 128 units, whatever it is. So every one goes to 128. Okay, and scale factor is the number when you divide the model divided by the original. So 1 divided by 128, which is a really small number. And you can get the decimal if you'd like, but as long as you have that ratio, you're okay. So this is like 0.0078125. It's a tiny number. But like I said, it's as long as you have the ratio, you're okay. So let's take a look at what this ratio can do for us. If we know that the model goes on the top, the original goes on the bottom. Okay? And you'll have like 5 or 6 multiple choice questions just like B here. Just like B here. So it says if the airplane model has a wingspan of 30, what is the wingspan of the actual? So as long as you understand that the model goes on top and the actual goes on the bottom, you're going to be okay. Model on top, actual on the bottom. Use this guiding ratio. That's what I'll call it here. It's like your guide. It will help you with all your scale factor, multiple choice questions that involve dimension. Okay? So 30 times 128, and you get your answer. So 3,840 centimeters after you cross multiply. So I think you guys should try number 2 and number 3, and then I will go over them with you. So please try number 2 and number 3. I think they are identical to part B here. Set up your ratios and cross multiply divide. So number 2, did it actually ask you to solve for anything, or just say find the scale? Find the scale. So yeah, so what I would do is I would put the 7 centimeters, which is the model, in the first part of the ratio, 350 kilometers in the second part of the ratio. Okay? That's it. Now if it asks for scale factor, which it didn't, then you need same units. It didn't, so I wouldn't worry about it. So like, how do we change this question so that we actually have to solve for something? That's number 3. Okay, so try number 3. If a man is 1.3 centimeters tall and a flagpole is 4.8 centimeters tall in a photograph. So those are both examples of models. Then it says the man is 190 centimeters in real life. So that's an original. Then it says how tall is the flagpole? That's another original. Okay, so partner up the models and originals. The man goes with the man, and the flagpole goes with the flagpole. So 1.3 centimeters goes with 190 centimeters. 4.8 centimeters goes with X centimeters, and cross multiply. 4.8 times 190, dividing 1.3, 701.5 centimeters. So that was a little bit of a variation, because as long as you are consistent with man goes with man, flagpole goes with flagpole, you're okay. So for example, if in number 2 they said that the distance between some other city was like 875 kilometers, and then they say, what is the distance on the map? This is for number 2. All you would have to do is put the kilometers in the right spot, right over here, and then solve for x centimeters. So as long as you're consistent with the units, you should be okay. Did you want that stuff? Question? Did you need that page still? What's up? Do you have a question about something? Okay. Any questions about scale factor and multiple choice questions? This is what the multiple choice is going to look like. Okay. Charlotte building a dollhouse. One of the windows is these 2 dimensions. Why are you late, big guy? Why are you late?
I was at a
Oh, the Amiscucci chip? Okay. Okay, so Charlotte building a dollhouse that is a scale replica of her own house. Okay, so you have a model and you have an original. One of the windows on the front of the house is 105 centimeters and 126 centimeters high. Is that on the actual house? Are these actual? It doesn't really say, it just says front of the house, so it must mean the original house. 105 centimeters, that's like a meter. So yeah, that's got to be on the original house. Okay. So then it says on the dollhouse, it is 7 centimeters wide. So 7 centimeters goes with 105 or 126? And how do you know that, buddy? Yeah. Good. Good. You have to match the dimension with the dimension. You can't start switching. You have to be consistent. So scale statement, model first, original second. 7 centimeters would go with 105 centimeters. What scale factor? It's nice because these are already in the same units. So 7 centimeters divided by 105 centimeters. For scale factor, because you're dividing with the same unit, the units actually cancel, and you just get a number by which you would times all the dimensions by. So it's 0.06 repeater. Then it says, what is the height? I would just cross multiply on these. 7 goes with 105. The height is 126. 126 is the original. Solve for the model for the height, which you'll just end up basically timesing by the scale factor. And you get x equal to 8.4. So hopefully the message is getting across that you just have to be consistent with the dimensions. Lengths go with lengths, widths go with widths, height goes with height. Scale factor has no units after they're canceled. That's why they need to be the same when you go to calculate it. So you need the same units for scale factor. For this statement, you don't need different units. Or you don't need the same units, pardon me. They can be the same, but they can be different. It does not matter. Because if you have a scale statement, you just use that to cross multiply and you keep the units consistent, you're okay when you cross multiply. Is that it for this page? Yeah. Okay, so on the next page we have the top, front, and side views, I think, and then a perspective drawing. Okay, so sometimes they mix these up. I'm not sure why the book does this. Usually the front is on the left, but it doesn't really matter. If they tell you, just follow what they've got. Otherwise, I usually put front on the left, but whatever. Okay, so let's start with front. It's over here on the right. So if you're standing over here by the front, what I would do is I would color in the face that you would see. Start on a column. So let's start on the far right, and you can see that these are going to be 4 high. And that's all you'd see from that. Then you see these guys on the front. Those are 3 high. And then 2 and then 1. Oh, for Mario 1? The original. Yeah, there'd be a flag right here, and he'd hop, 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 and then woo! Yeah. Yeah, go for it, buddy. Okay, so there's the front view. Then for the side view, I'd probably just switch my legend up. So now maybe I'll use X's. So now on the very first column, you'll have 4 rows going, or four squares in first column. Next column would have 3. And then the last column has 1. That's the side view. Okay, we got the front and the side done. So if you're standing here and here. Now the top's the weird one. Some people get this mixed up. So, what did I just do? Okay, so the top, you have to imagine, so like you're looking down at it this way. Because the front, this is the front. So the top always depends on the front. So the top view, I'll use circles for these ones. It's going to have 4 across the top row, like that. 3 on the far right, 1 right beside it. Yeah, and that's it there. So this black line that I sketched in with the big thick black line, that's like right here. So you have to use the front when you're doing the top view. That's the only one that would get confusing. Okay. Do you guys still need this page? Going once, twice. All right. Now, perspective drawing, I really don't think any of these are on the test. But just in general, what you want to do is connect all vertices of the object to the vanishing point. So that's called the vanishing point. Miss the side? And these ones are going to be behind, so I'm not going to cut across the object, and then just pick a length that you're going to stick with, and then cut across. That was terrible. Cut across. And then you got to, so you're basically drawing horizontal lines and vertical lines. So that's how you know when to cut it off. Thank you, thank you. Oh, right here. No. Just cheat. The line tool. You guys have rulers. Okay, that's what I came up with. It's not the best, but she'll do. Yeah, that's glitchy, eh? What have I done? Oh, I should have made those longer, shouldn't I have? Like that? Oh my gosh. Not the best artist, if you can't tell. Okay, so that's a little bit better. That's why we bring a pencil to class, not a pen. The vanishing point, I think, was somewhere over here. I erased it. Alright. So that's not bad. Okay, now the hard part. Oh my gosh. We have to draw a chair on an isometric dot with the proper dimensions. And they've given us a front view. What the heck is that? Okay, Christian's going to do this because he's a man. Here you go, buddy. I'll take Christian's book. This guy's a machine. Okay, I'm not taking credit for this. This is all Christian. Okay, so it's 90 centimeters high on the front view. So I'm thinking now you're going to grab 9. How many do you grab? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, he's using a scale of one line. Sorry, one line equals 0.5 centimeters. So every line he draws, and I'm just copying, don't want to take credit, is going to be half a centimeter. So if you can see that, like, on the far left of your page, it says 90 centimeters. Okay. You're going to need 18 lines. Sorry, one line would be, okay, let's just say that this is 9 centimeters. Cross out the zeros. 3.5. Okay. Okay, let's draw the 18 lines. Start near the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, you don't have to edit the, I apologize for this. You don't have to edit these. Let's just say one line is 5 centimeters. I'm being crazy. One line is 5 centimeters. So erase that crap right there. So let's take a look at the width of the chair leg. You see how it's 10 here? So if one line is 5 centimeters, two lines would give you the 10 centimeters. Now remember what I told you about isometric dot drawings. This is, what have we drawn so far on this vertical line? Vertical lines are the heights. What happens with the lengths and the widths? They go up to the left and up to the right, like into the page, out of the page. Josh, you okay, buddy? Looking a bit glossed over there. No, Leslie here. So we need 2 into the page. 2 into the page. And then you just draw your parallel line that would connect this. Okay? Okay, and what you have created there is sort of like the side view of one of the legs. It will, yeah. It's okay though. So let's go up to the top of this. So this whole thing is 90. This to here is 35, and this to here is 10. So 90, take away 10, take away 35 is 45. Good. So this distance here is 45. So it's 45 centimeters before the backrest reaches the chair. So if one line is 5 centimeters, how many lines for 45 centimeters? You just got to go like this: 5, 10, 15, 20, 25. Next thing you know, you're at 45, and it's 9. Okay, so you got to count down 9 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you can start the width of the chair seat. Somebody help me. How wide is the chair? Look at the side view. See the side view where it says 10, 30, and 10? So is it 10 and 30 for the seat, or 10 and 30 and 10?
Well, for which?
Just the seat.
If I have a front view, then it says 40 wide.
It's 40. So you need 8 lines here. 1, 2, 3, 4, 5, 6, 7, 8. How'd I get 8? See this? That's what we're building. And it's 10 and 30. Now we have to match this up here. So it's going to go to about there. No. This one you really have to stay concentrated on and do all the little details. Okay, so now you're starting to see how the chair is taking its shape. Okay, now let's take a look at the seat. How wide is the seat on the front view? It's 40 as well. Okay? So I think we got to go. It's a square, I think. It's a square seat. It's 40 by. Well, let's take a look at this diagram here. Or this goes to, that's 35. This is 10. Where's the width and the length? Oh, okay, so 40. There's no top view to tell us the length of this thing. Okay, let's just assume it's a square. So we'll go 8 by 8. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And you've made your seat. Now the legs, we have to finish off this bottom leg. The legs are 2 lines. The width of the seat is also 2 lines. This is so much fun. Okay, how to make the distance for the next leg. So from here and down, it's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2. Back up 7. 2. Back up 7.
They're not like that either, by the way. It's flat on both sides.
Correct. Thanks. Yeah, Christian's right. Because of the front view, look at the front view. See how it's just a big block? It doesn't have like the legs indicating that it looks like a chair like that. So I screwed up. I think the best way to do this is learn by mistakes though, so I don't know. It's okay to make, it's not an excuse. Brutal. Undo.
Yeah, there's 1, 2, 4. Look at the corner of the seat and then the same bottom.
I have to get rid of this line. And I'd have to clean up this line as well. Delete that.
Oh, no.
No.
You need to extend the rest of the way over. That connects to the back part. Yeah, it connects to the actual back piece. It's all one piece, so it's like. So that small 2 line is connected to the back of the chair.
What are you guys saying? Good enough?
Yeah, the back.
What are you guys saying? Good enough? Good thing Christian had this done already. You would have seen some weird stuff up there. So what to expect on your test? Not a chair. What do you guys think is going to come on your test? A prism. Yes! No. It's going to be definitely going to just be a prism. It's going to look like on your practice test. Right on the first page. So you can just that'll help you just copy it on the test. Okay. And if you've lost your practice test, there's more up here. Okay, next thing they have is component parts. So I don't know if you guys remember this. This is the IKEA furniture things. So there's 4 legs. So I would just say 4 times, and then I would just sketch in the leg. Just copy what's on the page next to you. That's all I'm doing. Yep. And then put in the dimensions just to be sure. 30 by 7. So it's 4 of those. And then you have the tabletop. And again, I'm just copying what I see. Nothing special here. Put in the dimensions and you're going to be okay. And there's only one of those. Okay, so those are the component parts. Now they're asking us for some scale statements. I'm not sure. Oh, I guess you're supposed to use a ruler or something. So don't worry too much about the scale here. And then the exploded diagram, like, you would just have to imagine. So draw in your tabletop.
I mean, if it's just a table that's like that, though, it's kind of hard to see how it wouldn't turn into it's 4 legs and just that. Kind of straightforward.
It's so easy, yeah. Just like, what you have to do is, this is hard. It's just hard on the damn iPad. So with the exploded view diagram, you have to somehow like show how they would connect. Okay, and I'll just do one to show you how it connects. You have to draw dotted lines to show how the components connect. It's just a prism. Just like this, I just said. Yeah. And you can literally just have this beside you and it'll help you. So make sure you grab the practice tests. No. Those are hard. Okay, so I think that's it for the chapter review. So we'll cut it off there.